So after discussing all the different methods of factorization, that is factorization by the method of common factors, factorization by the method of regrouping, factorization using identities, and factors of the form x plus a multiplied by x plus b, it's time to solve some problems based on those factorization methods. If you haven't watched those tutorials, then you can watch them. You can find the video links in the description box below. Watch them. I highly recommend you first watch them so that you can understand this tutorial properly. Okay, so let's begin. Find the common factors of the given terms 12x and 36. So 12x and 36, you can write this 36 as 12 multiplied by 3 and this as 12 multiplied by x. Now clearly this 12 and this 12 in these two terms is common, right? So the common factor will be 12. Now if you cannot quickly calculate like this, then the best way is what we discussed when we were discussing factorization by the method of common factors. The best way is break this down into irreducible factor form. This is 12, so 2 multiplied by 2 multiplied by 3. That is, write this 12 in its prime factor form, then multiplied by x. This 36 is 2 multiplied by 2, that is 4, multiplied by 3, that is 12, multiplied by 3, that is 36, right? So it's the prime factor form of 36. Now this 2, this 2, this 2, this 2, and this 3 and this 3. These are common. So 2 multiplied by 2 multiplied by 3 is common. That is equal to 12. So 12 is the common factor, right? Okay. The next one is 2y and 22y. Now again, this 22y can be written as 2 multiplied by 11 multiplied by y. The prime factor form of 22 is 2 multiplied by 11. And this 2y is 2 multiplied by y. So clearly this 2 and this y, the two factors are common and the common factor is therefore 2y, right? In this third one you have 14pq and 28p squared q squared. So 14pq and 28p squared q squared. Now if you can quickly calculate, then this is actually 14 multiplied by 2 multiplied by p squared multiplied by q squared, and here you have 14pq. So it means that this is p squared, it means it's p multiplied by p, and this is q squared, means q multiplied by q. So 14 and 1p here and 1p from here and this q here and 1q from here, this is common. But if you're not able to calculate this quickly, then the best way is the irreducible factor form, to break this down into its irreducible factor form. This is 14pq, so 2 multiplied by 7, the prime factor form of 14, multiplied by p multiplied by q. This is 2 times 2 is 4, 2 times 2 times 7, 2 times 2 is 4, times 7 is 28, then p multiplied by p multiplied by q multiplied by q, right? This 2, this 2, this 7, this 7, this p, this p, this q, this q. So 2 multiplied by 7 multiplied by p multiplied by q, this is common, that is 14pq is common. In the next one we have 16x cubed minus 4x squared 32x. Okay, so 16x cubed, you can quickly write this as 4 multiplied by 4 multiplied by x cubed, and this one as minus 1 multiplied by 4 multiplied by x squared, right? And this one as 4 multiplied by 8x. Now here you have x squared, here you have x cubed, but here you have only one x. Here you have only one x. So 1x from this, 1x from this, and the x here is common. And then you have 4, you have 4, you have 4. So it means 4x is common factor from these three terms. But if you are not able to quickly calculate it, then best way is to break down in its irreducible factor form. So 16x cubed means what? 2 times 2 is 4 times 2 is 8 times 2 is 16. Then x multiplied by x multiplied by x. Then this is minus 4x squared. So minus 1 multiplied by 2 multiplied by 2. Right? This minus is minus 1 here. And then multiplied by x multiplied by x. And then you have 2 multiplied by 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32 multiplied by x. Then this 2, this 2, this 2, this 2, this 2, and this 2. Right? So actually, in this case, you have only 2 multiplied by 2. So only 2 multiplied by 2 from here, 2 multiplied by 2 from here, and 2 multiplied by 2 from here. This x, and this x. Now you cannot choose more x from this one or this one because here you have only one x, right? It means that 2 multiplied by 2 is common in all these three, and multiplied by this x is common. X, x, and x. So this is 4x, right? So 4x is a common factor. Now in this case you have 3x squared y cubed, 10x cubed y squared, and 6x squared y squared z. Let's break it down. So this is 3 multiplied by x multiplied by x multiplied by y multiplied by y multiplied by y. This 10x cubed y cubed squared is 2 multiplied by 5 multiplied by x multiplied by x multiplied by x multiplied by y multiplied by y, right? And then this is 6, 2 times 3 is 6 multiplied by x multiplied by x multiplied by y multiplied by y multiplied by z. So from here this 3, no sorry, we can't take 3 because we don't have 3 in this one. So we can't take 3. And it means that we can only go with variables. So this x here, this x here, and this x here, this x here, this x here, and this x here. We can't take more x because here we have 2 and here we have 2. Then this y here, this y here, this y here, this y, and this y. Yeah, that's it. It means that x, y, y is common. So x multiplied by x multiplied by y multiplied by y, that is x squared y squared is common, right? If you can quickly calculate, then you can easily tell by just simply looking at these three terms. You can tell that only x squared y squared is common factor among these three terms. Here you have to factorize the following expressions. Okay, so this is 20l squared m plus 30alm, right? So 20l squared m plus 30alm. Now any person who is trained, that person can quickly tell the common factors from these. You have to use in this case factorization by the method of common factors, because here you have common factors in these two terms. You can write this as 2 multiplied by 10, right? Then l squared m and 3 multiplied by 10 alm. And you can quickly tell that 10 is common factor, and here you have l, here you have l squared, so l is common. Here you have m, here you have m, so 10 lm is common, and therefore if you write this in this way, this will be 2l plus 3a, right? So this will be the factorization of this algebraic expression. But if you cannot quickly calculate in this way, then again break it down, right? You have to break it down. So this is 20. It means that 2 times 2 is 4 times 5 is 20 multiplied by L multiplied by L multiplied by M. Then this plus sign here. 2 times 2 is, no, you cannot go in that way. So you can go 2 times 3 is 6 times 5 is 30 multiplied by A multiplied by L multiplied by M. So we have actually broken these two terms into its irreducible factor form. Okay, now this 2, then this 5, this L, this L, this M. So 2 multiplied by 5 multiplied by L multiplied by M is common. Remaining is 2L inside plus 3A. So you can write this as 10LM multiplied by 2L plus 3A. Right? So this will be the factorization of this algebraic expression. Now in this case, you have 10A squared minus 15B squared plus 20C squared. Okay. You have 4 different methods of factorization. Think which one you can apply here. Factorization by the method of common factors, factorization by the method of regrouping, then you have identities, and you have factor form x plus a multiplied by x plus b. Now clearly, this is actually factorization by the method of common factors. How? This is 10a squared, so 2 times 5 times a, right? Then minus, this is 15, 3 times 5, that is the prime factor form, multiplied by b, then this is plus, this is 20, so 2 times 2 is 4 times 5 is 20 times c times c. So this 2 here, no, you cannot take 2 because this term doesn't contain 2. So this 5, this 5, this 5, and then, yep, that's it. You have only one factor common, that is 5. So 5 outside the bracket, then you have 2a squared minus 3b squared and then plus 4c squared. So this is the required factorization of this algebraic expression. Now in this next case, you have minus 4a squared plus 4ab minus 4ca. Okay, now we can write this as minus 1 multiplied by 2 multiplied by 2 multiplied by a multiplied by a, and this one as plus 2 multiplied by 2, that is the prime factor form of 4, multiplied by a multiplied by b, then minus this one as 2 multiplied by 2 multiplied by c multiplied by a. Okay, so this 2, this 2, and this 2, this 2, this 2, and this 2, then this a, and this a. Only these 3 factors are common amongst these 3 terms of this algebraic expression. So 2 multiplied by 2 multiplied by a taken outside the bracket. Here you have now minus a, right? Minus 1 multiplied by a means minus a, plus b, and minus c. It means that it's actually equal to 4a minus a plus b minus c. So this is the required factorization of this algebraic expression. In this case, you have ax squared plus ax squared y. Let's break it down. So a multiplied by x multiplied by x multiplied by y, then plus sign. This is b multiplied by x multiplied by y multiplied by y. This plus sign. This is c multiplied by x multiplied by y multiplied by z. Okay. So a is not common amongst these 3 common factors. This x, and this x. This y, and this y, right? That's it. So xy is common, take outside the bracket. Inside you have ax plus by plus cz. So this is the required factorization, and we have used in all these four cases, we have used factorization by the method of common factors, right? Now here you have another 5 algebraic expressions and you have to factorize it. First one is x squared plus xy plus 8x plus 8y. Okay, now how will you do this? X squared plus xy plus 8x plus 8y. Clearly, this cannot be solved by the method of factorization by the method of common factors, because none of these amongst these four terms, there is not a single common factor. One term, second term, third term, fourth term. These four terms don't contain any common factor. Then what to do? Now here, if you look properly, you can apply here factorization by the method of regrouping. And how? This is x squared plus xy. Okay. Consider these two together and then these two together. So from here, you can write this as x multiplied by x, and this is xy. So x common, x plus y, right? We can write this as, then plus sign. You have 8x and 8y. 8 is the common factor amongst these two. So this is x plus y, right? So this is basically what? We have two terms, that is one term is this one and one term is this one now. And x plus y in this term and x plus y in this term is common. Take x plus y outside the bracket, that is the common factor. And inside you will have x plus 8. X plus y common, right? Take outside the bracket, so inside the bracket you will have x plus 8. Distributive property of multiplication over addition. This is the required factorization of this expression. Now, this is 15xy minus 6x plus 5y and minus 2. Right? How to do this? Well, again, factorization by the method of regrouping, not common factors, because in this expression you have four terms, but there's not a single common factor, that there's no common factor amongst these four terms of this expression. It means that here you'll use again the regrouping. Consider this one and this one. So this is actually 3 times 5 times x times y minus 2 times 3 times x, right? This one, and then this plus sign, write this as 5y minus 2. Okay. Now basically, in this case, this 3 and this 3, and then this x and this x. It means that of these two terms, out of these two terms, 3x is common in both these two terms. So take 3x outside the bracket, inside you have 5y minus 2, then plus this 5y minus 2, right? Now, this expression has two terms. One term is this one and one term is this one, right? So basically this is what? This is 1 multiplied by 5y minus 2, right? So this factor is common in both these two terms. Take this out of the bracket. So 5y minus 2, this one factor is common in both these two terms, taken outside the bracket. Inside the bracket, you are left with 3x and then plus 1. Distributive property of multiplication over addition. So this is the required factorization of this algebraic expression. Now in this case, you have ax plus bx minus ay minus by. Okay, what can we do in this case? Well, again, regrouping, because you don't have common factors amongst these four terms, group them together, right? In this case, you have x and x, take x, the common factor x amongst these two terms outside the bracket, and you have a plus b. Then here you have y and y, take y outside the bracket, and in order to get a plus b as a common factor in these two terms, take y minus also and outside the bracket, and then you have inside you will have a plus b, because when you open the bracket, this is minus y, so this becomes minus ay, and this minus y, so minus y multiplied by plus b means minus by, exactly the same. And why did we take minus outside? Because actually we need this a plus b as a common factor in these two terms. The two terms are x multiplied by a plus b and y minus y multiplied by a plus b. Why minus we are taking with this term? Because we always take the negative in the next term. So these are the two terms, and here a plus b is common, so take a plus b common factor outside, inside you have x minus y. So this is the required factorization of this algebraic expression. Okay, now in this case you have 15pq plus 15 plus 9q plus 25p. Okay, what to do in this case? Well, if you look this expression carefully, then let's group these together. 5p, we can take this, 25p and this one. Let's do 3, 5. Okay, let's group 15pq and plus 25p together, and then this plus 15 and this 9q together. Okay, now this 15pq is basically what? This is 3 times 5 times p times q plus 5 multiplied by 5 multiplied by p, then this is plus, this is 3 multiplied by 5 plus this is 3 multiplied by q. We have reduced each term into its irreducible factor form. Now when you take these two together and these two together, so actually 3 here, now we are applying in these two terms, we are applying the common factor, the concept of common factors. 3 here, so we cannot use 3 because this term doesn't have 3, so 5 here and 5 here, p here and p here. Okay, let's take 5p outside, so 5p, inside you have 3q plus 5. Okay, now these two terms, in these two terms you have 3 here and 3 here, that's it. So take 3, the factor 3 common outside, inside you have 5 plus 3q, right? Now we can write 5 plus 3q as 3q plus 5 because we want this factor to look same, right? So look alike. So write 5 plus 3q as 3q plus 5. Now we have two terms, one term is this and one term is this. This factor is common in both these two terms, so 3q plus 5 outside the bracket, inside you have 5p plus 3, right? So this is the required factorization of this expression. Now this is fourth one, and here you have z minus 7 plus 7xy minus xyz. Okay, what can we do in this case? This is z minus 7 and this is 7xy. What we can do is, okay, let's group like this. Take this z, right? We cannot use the common factor factorization by the method of common factors because here we have 1, 2, 3, 4 terms, and they don't contain any common factors. So this is z and this is minus xyz. Group them together, then this plus sign, this one plus 7xy, and then this minus 7. So we are going to take these two together and these two together. So from here, this is z here and z here. Take z outside, the common factor. So inside the bracket you'll have 1 minus xy. Okay, this plus sign here. You have 7 here, you have 7 here. Take this outside. So you have, in this case, you have xy minus 1. Okay. Now here you have 1 minus xy. Here you have xy minus 1. We can do one thing. Let's take minus outside. So if you take minus outside, inside will become 1 minus xy. If you take minus outside, this will become 1 minus xy. How? So 7xy minus 7, right? So basically what we have done, we have taken minus 7 outside. Let's take minus 7 outside. So let's first take only 7 outside. So this is 7 xy minus 1, right? Now I can write this as 7 minus 1 plus xy minus 1 plus xy. Now this is basically what? 7 minus 1 multiplied by 1. We can write this minus 1 as minus 1 multiplied by 1. Any problem? No. Plus minus 1 multiplied by minus 1. This is basically what? 1 only. xy. Any problem? No. This minus 1 is common in both these two. Let's take this out. So minus 1 multiplied by 7. Inside you have 1, and then you have this minus 1 here. Minus 1 multiplied by xy means what? Minus xy, right? Minus 1 multiplied by x is minus x, multiplied by y is minus xy. This is minus 1 multiplied by 7. This is minus 7, 1 minus xy. That's what we have done here. Simple, right? Okay, so we have two terms now, this and this. Because why we are taking minus in the next term? Because if your coefficient is negative, you always take the negative sign with this next term. Okay, so 1 minus xy is common. Let's take this out. 1 minus xy. This becomes z minus 7. This is the required factorization form of factorization of this expression, that is z minus 7 plus 7xy minus xyz.